Alright, so example 4, we're going to be using the definition of logarithm, and if you recall, that's using the loop rule. So the base raised to that exponent is equal to the argument of the logarithm, that part right there in parentheses. So we convert this thing into an exponential equation doing that. So 3 squared, so the base raised to this power, that's the 3 squared, is equal to the argument of the logarithm itself, log of 3p. So 3 squared is 9 equals log base 3 of p. Now apply the loop rule again. 3 to the 9th is equal to p. So 3 to the 9th equals p. So p equals 3 to the 9th. That's our answer right there. We solved for the variable. The variable is right here. We solved for it. We're done. That one was pretty quick. Next is example 5, and that should be the last one for this lesson. For example 5 here, we have 5 to the x equals 3 to the 2 minus 4x. So at first glance, this is a standard exponential equation. Exponential equation because we have exponent variables that are set equal to one another, and we need to solve this thing. Well, unfortunately, a base of 5 and a base of 3, we have no way of doing what we did in the previous unit when we worked with exponentials, but to set the bases the same. 3 and 5, we can't make those bases the same. So this is where we need logarithms to help us solve this. So it's appropriate to use them in this case. So I can take the logarithm of both sides. I'm allowed to do that because they were set equal to one another in the beginning. So this is equal to this. Therefore, if I take the logarithm of this, I can set it equal to the logarithm of this. As long as I take the logarithm on both sides, everything's still equivalent. It's okay to do. Then I can apply my logarithm theorem that says if I have an exponent in my logarithm, I can pull it in front as a multiplication. Doing so unlocks that x from that exponent location. It gets it down here so I can work with it. That's the whole goal. Same thing here, pull this in front as a multiplier. Just realize this is a whole quantity times this log base 3 now. You can't just pull the 2 down or just pull the minus 4x down. You have to bring it all together. Now, we discussed in the beginning of the video that this, for example, this log of 3 is simply a number. It's just a quantity. So I'm allowed algebraically to distribute it inside here, and that's what we need to do. That's what we're going to do. So x log 5 equals 2 log 3. That's this 2 times this log 3, and then minus 4x log 3. This is this negative 4x times this log 3 right here. Alright, so far so good. Now, the goal of solving for this x is to get all the x's by themselves on one side, right? So notice that this quantity right here has no x included in it, so I'm going to leave it on the right side, but I want to move this whole chunk over here. This is one entire quantity here, so it's okay to add it. It's a negative quantity, so it's okay to add it to both sides, so that's what I'm going to do. All I'm doing is moving this whole chunk over to the other side so it'll become positive. So in the next step, I have 4x log 3 is equal to plus x log 5. So this is still there, and now this is over here on the left side, is equal to the original right side, 2 log 3. Next, we notice that we have an x factor. Why factor? Because it's being multiplied in here. This quantity is 4 times x times log 3. This is x times log 5. So I'm multiplying by x in both terms. When you see something like that, when you're solving, the most common approach is to factor it out. So I'm going to factor out this x in the next step. So I have x times 4 log 3 plus log 5. Okay, there I just factored out an x from this and this. And that is equal to, I should have made more room to allow for the extra space that I need. I'm going to have to cover this up because we're running out of room. So I have x 4 log 3 plus x times the quantity 4 log 3 plus log 5 is equal to this 2 log 3 right here. And now that I have that, I can just divide by this whole chunk right here. 4 log 3 plus log 5. I do the same thing over here. 4 log 3 plus log 5. And I get x equals that whole thing right there. I'm going to have to write it again, unfortunately. That's a lot to write. 4 log 3 plus log 5. We don't have a calculator on this unit. This would give you some decimal value, but we are going to leave it in this form right here. So example 5 is done. Again, it is equal, x is equal to 2 log 3 divided by log 5 plus 4 log 3, or the order down here doesn't matter. It can be 2 log 3, 4 log 3 plus log 5. This denominator can change order. I could have written log 5 plus 4 log 3 down here. Okay? Either way, it's equivalent. So we are done with example 5. You may have to go through this a couple of times. It's not uncommon in the beginning for these logarithm equations to be difficult for students to work through. So if you need to watch this problem again, go ahead. That's it for this lesson and this video.